Thank you, Jeremy and Kayla, for inviting me today. I just wanted to open by clarifying what it is that Cal OES Fire and Rescue does. We are a support agency to frontline response organizations in California and both nationally and internationally. So we don't necessarily put the fires out, but we provide equipment and manpower to help the agency having jurisdictions at the events do that work. And so we're here today to talk about Fire Integrated Real-Time Intelligence System. Next slide, please. So Fire Integrated Real-Time Intelligence System is an idea that you can leverage modern technology and aircraft to gather intelligence about things that are happening in the environment. Now, we were born out of fire, but we're doing more than that now. One of the reasons I think I was invited here was to talk about some of the stuff we're doing in public emergency management, specifically with infrastructure. So next slide. A little bit about the FIRES platform. The FIRES platform is a 24-hour-a-day, 7-day-a-week operational program. We fly 2 aircraft, one in Chino, Southern California, and one out of McAllen near Sacramento. And we have 2 shifts a day from 8 in the morning till 2000 at night. And each one of those shifts has a mission commander, a qualified airborne sensor operator that manages the sensing capability of the aircraft, and a pilot in command. And again, that's 24 hours a day, 7 days a week, 365 days a year. Additionally, the vector the aircraft to places where it needs to be. And we also have a modeling wing, and we'll talk about that more in a minute. Next slide, please. So a little bit about the aircraft. These are King Air B200 aircraft. They are equipped with a suite of sensors. Starting from the top going down, there's a KA-18 satellite uplink. It's capable of about 20 megabits, so about 720p HD live stream capability. We can't do both things at once, so if we're trying to download data out the aircraft, we have to turn off the live stream and let that data flow from the aircraft out to our customers. We have a FLIR 380 HDC sensor. We have a TK8 sensor now that we just upgraded. We'll talk about these sensors in length shortly. We have a Terrain Mapper 2 LiDAR system. And we also have a NPS 7, which is a synthetic aperture radar. And then finally, on the bottom of the aircraft, we have an MPU 5, which is kind of a warfighter type mesh network system. If you have firefighters on the ground or responders on the ground with an ATAC or tablet command type system, the information from the aircraft can flow directly to the ground, not having to make the jump up into space and then back down ground-based or cellular type connections. Next slide, please. Glamour shot of the airplane there at McAllen. And the slide on the right is the interior of the aircraft. What you're looking at there is the ASO station. There's several computers and equipment that make it all run. One of the major limitations of the aircraft and the program is that we're right on the edge of the amount of power that the aircraft is able to generate in order to run all these sensors. So we have to ask before we go fly, what is it you want us to do, so that we can prepare the aircraft with the proper sensors, or at least make it known that we can't do everything all at the same time. We have to make a decision about what we're going to do. If you look to the front, you can see the pilot station there. The pilot flies on the left, and then the mission commander will fly on the right to help with cockpit resource management. And then they'll move to the back of the aircraft during collection to help the ASO better understand what the target is and what the objective of the collect is. So next slide. So if anybody has ever heard of the FIRES program before, this is where I give a shout out to Chief Brian Fennessy from Orange County Fire Authority that had the vision to find the funding and the people to build a program that took a basic sensor package, a 380 and a TK sensor, and some cellular connectivity, and go out and find fires in the wildland. So there was a plane, there was a way to collect data from the environment. So again, think back to cameras. Originally, this program was in Southern California only. So they were listening to the dispatch centers when there was a wildfire. They would launch the plane, and it is basically where's the fire, how big's the fire, where's the fire going. And again, on the right hand side there, you see a little bit of the fire modeling aspect of what we do. We'll talk about that on the next slide. So a standard product set from Fires in the Wildland arena is a model. That picture on the left is a wildland fire model. We use Farsight. We use static weather. We are working on bringing that into more of a probabilistic type model. More to follow on that. You have a picture in the middle. That is a infrared representation of the fire, where it's hot and where it's not, basically a perimeter. And then on the left is a slide from either a full motion video or a picture of what's happening. You can see that is the Palisades fire moving towards the west, coming down off the hill into some structures or some values at risk. Next slide, please. And then additionally, we can push out more graphical representations of the fire. The picture on the right is just a snapshot of, or a screen grab from a common operating picture. It gives you a little bit better idea about where the fire is in terms of the structures. And then that on the left is a screen capture, and I believe that was the Palisades fire. Again, at nighttime, but for a fire commander or a fire manager or responder on the ground, that's valuable information that lets them understand what the possible impacts of the fire are and where to best deploy their resources. All right, next slide. So some of our successes, we create unique partnerships, specifically California and Ohio Patrol, Civil Air Patrol, California Department of Transportation, and Geologic Survey. And we help out trying to understand how avalanches, earthquakes, and the movement of earth impact what we do in the state of California. We stood up a blob storage solution that transition our access to data to our partners in a more secure and robust way. These sensor packages generate massive amounts of data, and we're just not to the place anymore where we can pass thumb drives around or just take pictures. We'll talk more about some of the data that we generate. We provide real-time customer support. In the event that your agency needs something from the fires program and can't readily interface with our distribution systems, our Fusion Center will work with you to get the data where it needs to be so that you can utilize it in a advantageous fashion. We maintain a 95.6% uptime. Basically, that means that the air, except for periods when there is mandatory maintenance, we are available 23 out of 24 hours a day, which I think is pretty good because, you know, a plane is not a car. You have to maintain it. And when it doesn't want to work, you can't just go out and fly it. So we are very proud of our subcontractor, Dynamic Aviation and Avix Aerospace, for providing the aircraft at that level of readiness. And we're, let's see, aviation program availability during high impact weather events. We strive to have the aircraft available to fly. Unfortunately, during the events of January 7th in Southern California, historical levels of wind, our aircraft was grounded at the Chino Airport, which means we had to vector the northern aircraft down, which was an additional about 4 hours of flight time. But we were able to get down there and do that. We have since made changes in the program to address that so that we can have a higher uptime during impactful periods. Next slide, please. So in terms of training efforts, we maintain an annual training program that ensures flight crews can conduct safe flight operations and aerial sensor correct proficiency. We participate in the joint all hazards assessment and awareness exercise with our partners at Department of Defense. We practice what we will do in the event of an impactful event. So earthquake, flooding, biological release, or improvised nuclear type detonation. How are we going to go out and provide information back into the State Operations Center or headquarters here at Cal OAS, and then again out to the responders on the ground so they can make good decisions. And we're also beginning an effort to create mission profile standardization so the customers and the public understand what our capability is. And when you ask for a flood inundation product, you understand what you're going to get at the end. You can be prepared for that data when we provide it to you. and everybody's on the same page about what the capabilities of the program are. Next slide, please. So really quickly, the four things that we do the most, obviously, are wildland fire. We do training. We maintain a training regiment. Airplanes don't like to sit, so we like to get out and fly them about every 48 hours. We participated in a lot of search and rescue with our partners here at Cal OES on the law side of the branch. And then that other is some of the flight time that's increasing, sensor testing, general aviation requirements, and new and exciting ways to leverage the sensor packages. So next slide. So those are data collection. Aerial data can be requested by the customer and can require additional post-processing. So mud and debris flow, landslides, damage assessments, infrastructure inspection. And we also can do reconnaissance, no notice aerial collections of assets or of potential impacts that could be benefit from fire support. So we can go out and take pictures or full motion video of earthquakes, hazardous materials, hurricanes, landslides, avalanches is another one we do. Swift water, we've been involved with that. Maritime hurricane, we had Hurricane Hillary, I don't know, 18 months ago, I think, that impacted Southern California. We flew we flew beach erosion missions to get a better idea about how the beaches fared during that event. Next slide. So our flight hours, we flew in 2023, 824 hours of flight time. In 2023, that represented about a little less than 50% of all the IAA hours flown in the country in wildland fire, and not counting anything that FEMA is doing, but generally in the emergency management and wildfire world. And you can see a major slice of that is wildfire, with about 20% being training and the rest being data collection and search and rescue. Next slide. 2024 saw about a 20% increase, so 1,000 flight hours. 2024 was a very large wildland fire year. We counted everything that we did in support or a second or third order fire effect to be a wildfire collect. So there's some data collection we did for mud and debris flow. We'll talk about that shortly. Or impacts to roads, that gets counted in there. But you can see, obviously, our training hours went down quite a bit because you don't need to train as much when you're always going out and flying. Data collection, search and rescue remained about the same. So next slide. So you can see that there was a major increase in 2024. Another part of that was that during 2024, there was major fire impacts both in U.S. Forest Service Region 6, which is Oregon and Washington, and U.S. Forest Service Region 3, which is Arizona and New Mexico. Their fire load significantly reduced the available IAA capability in California, and FIRUS stepped into that role to provide support while other IAA assets were brought online by our partners, both at U.S. Forest Service and our state partner, CAL FIRE. All right, let's talk about sensors. Next slide, please. So sensors and data acquisition. The primary sensor that you would see a picture of if you are watching the news or see general data from the program is the Starfire FLIR 380 HDC. So this is a standard ball mount sensor. It senses in infrared and electro-optical. It has laser range finding capability. It has target tracking capability. And it's basically just a fancy camera on the bottom of the plane that can auto track, and it gives pictures and range information about targets in the environment. Next slide. So here's some data collection. Next slide. So February 18th, 2025, there was a train derailment. The Tehachapi Circle, I think this is, coming from Bakersfield, headed up into kind of Lancaster, the high desert east of the LA basin. Train had derailed. There was some concern that there could be some impacts from hazardous materials in the train cars. And so we flew this mission in support of our partners at National Transportation and Hazmat. These pictures are taken from about 10,000 feet and an off angle of 45 degrees, so a good 15,000 feet away maybe. And if they really zoomed in, you could probably see people. It's a little bit too far to see the placards on there, but if you needed that, we could get a little bit closer. Next slide. And that right there is about the limit of what we can do at 11,000 feet. And we usually fly 10,000 feet above the target. And so that target, yeah, is 4,300 meters away, about 2.7 miles. You might be able to get a little tighter than that. But again, if you needed to see the placard, you could do that. You could definitely see responders on the ground. I see two people standing there next to a dozer and some trucks. It's pretty amazing what these sensors are capable of. Next slide, please. April 25th, 2024, Orange County Pier Fire. The fires program was made aware of a commercial fire at the end of the pier in Orange County. The fusion center managers vectored the aircraft to the incident, and we were able to provide real-time intelligence to the firefighters that were fighting this fire or suppressing this fire. This is at the end of a very long pier. I want to say it's like 1,000 feet long, maybe a quarter mile. So it was a long hose lay out there. In the picture on the right, you can see the helicopter dropping. That's a shortwave infrared picture. And you can definitely see the heat coming off of the incident. Next slide, please. And so in this picture here, you get a better understanding of what is on fire, what's not. Picture on the right, you can see the reflection of the infrared energy coming off of the water. That's more of a long range infrared picture there. But moving back to the left, you can see the fireboat. The fire commanders were able to determine that the integrity of the pier just to the inland side of that building was safe, and they were able to extend a hose lay out to that in support of the ocean-based fire apparatus. Next slide. This was the LA County Seaside incident. This was a semi-truck that was moving a prefabricated battery boosting type machine. I'm still a little unaware, or I still don't quite understand what it was, but I think it was something that you would put like where a battery charging, like a battery bank would go, and you would put the main power into it, and it would store that energy. So during high peak loads of lots of cars charging at the same time, this would provide supplemental power. So this vehicle rolled over. It looks rather benign. However, if you go to the next slide, you can see that it's really hot in there. They moved the aircraft around. They got a better shot down low at the piece of equipment. Again, the long wave infrared, it's kind of blown out. Long wave doesn't do a good job of really pinpointing it. However, the picture in the upper right was able to be utilized by the incident commander along with the manufacturer of the device, and they could tell exactly which battery is on fire and what that meant in terms of suppression and how long it was going to take to mitigate that hazard. Next slide. So the next sensor we have that we use, one of the largest amounts of data that we create is our Overwatch TK8 sensor. This is a sensor that scans back and forth across the landscape. We get about 70 degrees of a scan each time it goes back and forth, and it's a multispectral scanner. It scans in shortwave, midwave, long wave infrared, RGB, near infrared, and any mixture of those two things. So it can take pictures, but it can also do mapping, and it is the primary mapping for wildland fire that we do. Overwatch and AVEX Aviation provides a proprietary piece of software that looks at the infrared composite images and generates the fire perimeters that we saw earlier, but does lots of other things too, and we'll explore that now. Next two slides, please. So the Arroyo Seco, a little bit of area orientation. This area is south of San Francisco, and more specifically, it's just south of Carmel Valley in Monterey County on the central coast of California. So next slide. This is a Google Earth image of the landslide. That is a kind of a decomposed granite, a loomy kind of soil that's sliding down into the Arroyo Seco River right there. And there's a major thoroughfare, a road right there that you can see that needs to remain open. And our partners at California Geologic Survey and Caltrans are very concerned about the movement of that landslide, so much so that they used to send survey crews out every year, or I've heard varying reports, but every once in a while they'd go out and they'd have to survey it to see how it was moving. They asked us if we could fly the TK sensor in support of digital elevation models, and we obliged. Next slide. This is a representation of what that data looks like. It's just picture. It is a picture. However, we fly high overlap strips, meaning that each individual spot on the landscape is photographed from 8 different strips. And you can do some math and you end up with a 3D elevation model. Next slide. So California Geologic Survey took that data and they generated this model here. And this is super cerebral, so I always have to look at it to make sure I'm talking about it right. This is the the horizontal movement. So flat across the ground. You can see that the slide is moving to the south in this representation here. That's a great picture. Yes, it is moving, but more importantly, how is it moving vertically? Next slide. And here is a representation of the movement of the slide vertically. You can see the red, it's sinking. Obviously, there is a fissure opening up at the top of the slide. The graph that you see on the left there is a representation of the line kind of moving from the northwest to the southeast. A little dyslexia there. I gotta get it straight in my head. But you can very plainly see that there is a large vertical movement, and I believe that vertical movement is 2.5 meters down at the bottom. So that ground is sinking. Interestingly, down in the Arroyo Seco drainage right there in the bottom left of the picture, you can see large chunks of material that have fallen into the river, and that you can see the scouring around it from the last water event. So amazing resolution. These digital elevation models are good down to about 10 centimeters. So not quite survey quality, but definitely enough quality to tell that you've got a large amount of material that's moving. And if that ends up on the road, we can get a better understanding of how much and how long it's going to take to move it. Next slide. We also can do digital elevation models of mud and debris flow. Next slide. So this is a product that we generate in support of California Geologic Survey. And again, there's a long connection between this and what my colleague Eric does. We were asked to go out and collect digital elevation models through TK sensing of a fire. I believe it was the Butler fire, kind of outside of Lancaster there. U.S. California Geologic Survey then took that data and created models about what the current state of the landscape was, and then USGS combined that with highly accurate geomorphic, what kind of soil is there, and they created an output that talked about the risk of a debris flow for a given amount of rain. Okay, so we're almost there. Bear with me. And so then if you take a model like a GFS rainfall amount model, and you say that there is going to be 20 millimeters of rain in a 1 hour period, then you can get a risk model that talks about the probability. You can get a probability model that talks about the chances of a landslide happening or a mud flow happening. These are highly accurate maps. We as OES don't talk about what the risk of the mud flow is or what the probability of rainfall is. However, we do assist the agencies when they ask for help based on data that is generated from these products. Next slide. And so, sadly, one of the other things that we do is we can do rapid damage assessment. These are examples from the LA fires, Palisades and Eaton. Next slide, please. And so I have to open this statement by saying it's not the job of Cal OES Fire and Rescue or the Fires Program to talk about what the impacts are. That is up to the agency having jurisdiction. We provide data, sometimes information that somebody else can turn into intelligence. However, it makes sense for OES to have an understanding about what the impacts are, because this piece of data information suggests that there were 5,204 structures that were impacted by a wildland fire, and that's 20,000 people that in the next 48 hours are going to need shelter and support. And it is advantageous for an emergency management or support agency to understand what the impacts are and to rapidly provide that assistance. So now that I've said that, we'll get on to how we generate these products. At the end of our collect cycle, we will fly one more time over the top of the fire, creating a quick mosaic of blended infrared products that kind of give an idea about where things are hot on the landscape. Our analytics team at UC San Diego will then compare that to building footprint data. And if there's concurrency between a hot spot on the ground and where a structure, where the building layer says a structure is, we will count that as a structure that has been impacted. These are by no means accurate numbers. However, we have found success. We're usually within about 10% of what the final number is. So again, we're not trying to jump ahead or speak for the agency having jurisdiction. We're just trying to get a better understanding about what the impacts are so we can provide support to the citizens of California. Next slide. A similar effort here on the Eaton fire. The Eaton fire was about 20 miles to the east of the Palisades fire. It started the night of the 7th, as opposed to the early morning or the late morning of the 7th of the Palisades fire. And again, we were able to overfly the incident. The green outline is the fire perimeter. However, we flew back over with the sensor tuned specifically to gather multispectral IR images, infrared images, and to generate this product. And this one said it was 6820 total structures affected, and I think those numbers are pretty close to what the DINS teams on the ground were able to collect. All right, next slide. So how are we evolving? So the fires program, while we do wildland fire and some of these other aspects, we are evolving. We are experimental in nature. We look for new and unique R&D applications of existing technology. And we have two new pieces of equipment that we're using, LiDAR and synthetic aperture radar. Next slide. So we recently acquired through our contractor a Leica Terrain Mapper 2 LiDAR sensor. This creates highly accurate three-dimensional depictions or models of the landscape, accurate down to centimeters, millimeters maybe. This is a really hard sensor to use and to get to work at that level of accuracy, but we continue to try and do that. Some examples of what we've done. Next slide, please. This is the Indian Valley landslide. This is just a little bit east of Clear Lake, kind of north of Sacramento a little bit if you're thinking California statewide. There is a area of land that is poised to slide down into this Indian Valley River creek. And if it does that, it will create a dam. Next slide, please. And you can see on the left-hand side of the picture, kind of actually dead center, you can see the slide kind of coming out of that east aspect right there. And down past the river and down in that valley down there is a town, and I forget the name of it, I apologize. But this was the original use case of our TK sensor. We had collected on this several times, and that was great data. And now we're trying to do LiDAR to see if we can get even better data. Again, once that slide slides into that river drainage, it will create a dam, and that dam, when it eventually erodes that earthen blockage, it will create a increased water flow down there. That would be not good. We don't want that. So this image is our three-dimensional model overlaid on a Google Earth picture, satellite picture. The sensor does have the capability to take pictures, or we could provide our own TK images over the top of it. That's a work in progress. That's not in our product set right now. We're still just trying to figure out how to take good LiDAR data and provide support to our partners with that. Next slide, please. And finally, the synthetic aperture radar. This is an MPS 7. This is kind of a military grade type sensor. It'll do moving target. It will do target designation. It's my understanding that if you put a Coke can on a freeway and then you fly 100 nautical miles down and come 100 nautical miles back and remove it, the sensor knows it's not there anymore. It doesn't know what it was, but it just knows something was there and now it's not. So this has great applications if you're looking for somebody, say, in the snow, or you're trying to determine how something that is static has changed. Next slide, please. So the use case for this was 2023, I think, when I first started here. The Pajaro River, just south and west of Salinas, California, had ruptured a levee in that area, and this is a community of approximately 5,000 people. We were requested to try and determine, the fires program was requested to try and determine how deep the floodwaters were. We flew the synthetic aperture radar in support of that effort. We gathered data. You can see that raw data on the left right there. We compared that with a publicly available Google digital elevation, Earth elevation model. We did math, and we found that the floodwaters were approximately 2 feet deep. You can see in the picture in the middle there, which was San Jose Mercury News from one of their helicopters, that there is substantial inundation around those buildings or structures. Turns out synthetic aperture radar is not good at highly cluttered and reflective environments. There are some filtering things that we can do to try and improve that. However, outside of the urban area, you can see that it was relatively accurate. If you zoom in on that picture in the middle, you can see that the water is about 2 feet deep. It's up about the middle of the grills on the vehicles. Those vehicles probably aren't totaled. The reason this is important is because, generally speaking, if a structure is not impacted above the light sockets in the building, you can just take the carpet out, cut the bottom of the drywall off, and the structure is inhabitable, right? After a little bit of work. However, if the water is above the light sockets, you have to tear out all the drywall. There's subfloor issues. Those individuals are going to need long-term assistance. And so if you've got 500 houses that have more than 18 inches of water in them, that's 2,000 people that you have to find housing and support for. Again, a great tool for OAS or our partners to understand what impacts are. All right, next slide. So a little bit of pitch about what OAS can offer. We have a common operating picture, or a COP, that is, if you are in emergency management or basically anybody in public service, you can scan that QR code right there and sign up for the Next Gen Scout tool. This would be a great place for you to find the FIRUS data. Anybody that's familiar with the Forest Service's EGP tool, they are brother and sister. Ours isn't quite as capable as EGP. However, the Forest Service has transitioned away. They now use Next Gen EGP, which is more of a ArcGIS online type product. And this is what we're using now, and you're more than welcome to sign up and utilize it. Next slide. If you want FIRUS data in real time, we use the Slack application. The Slack application was originally designed as a coding and programming platform for teams to work together. The OES needed a secure and archival type system in order to disseminate the data. This was the contract that we went with. It's not perfect, but it definitely gets it done. If you want the real-time products that the FIRUS program generates, this is the place to go. You can scan that QR code right there, and you can sign up. They're both Microsoft Sheets. The team with the FIRUS program will get you signed up for both of those applications. Next slide. Well, that's it. FIRUS integrated real-time system. One question that I get a lot is, how do you order it? We are a no cost to the end user program. We will entertain and attempt to do everything we can to help you. And if you would like to request it and you don't know how, you call the FIRUS duty line right there, and you'll end up talking to myself or one of the other assistant chiefs in Cal OAS, Fire and Rescue, and they will help you better understand what we can do to help you. If there aren't any questions, I'll throw it back to Jeremy.